Okay, so we're starting a new chapter today. 12 is all about matrices, chapter 12, and this is our final chapter in the book. And we're going to start off with adding and subtracting matrices. You'll find this section really simple and easy, hopefully. Okay, so 12-1 is about adding and subtracting matrices. I want to point out again that this chapter, we're going to do one lesson per day and then the test. On your test, the only thing I'm going to let you do, because there's no study guide, we're not going over it all for a day because it's so short, it's such a simple process, and I think you'll really enjoy this. We will just take our homework, what you're doing each day here. You're going to rip out 12-1, 12-2, 12-3, 12-4, and that's what you're going to have. And we'll grade these every day before you walk out of here. So there probably won't be any homework as long as we work quickly and there's not a lot of questions in class. So hopefully I'll explain this nice and clear and you'll get it, and we'll be done before the hour is over. So our objective is to add and subtract matrices and to solve matrix equations. On matrix is singular form of the term. Matrices is the plural form of matrix. Okay? So when we look at this quickly, it says, how can you complete the squares to show the number patterns in each square from one square to square? And from square to square. Explain each pattern. So what's our first pattern? What goes in this first box? 1. Then it goes 2. What's next? 3, 4, 5, 6, 8. That's it. So it was pretty simple process just to see, oh, that's just a sequence of 1. Let's look at the next one. Now, what is this box doing? What are we counting by here? 2's. So it would be 2, 4, 6, 10, 14, and 18. Very good. How about the next one? What is it counting by? So our first box is, I love it, 6, 9, 15, 18, 27, 21, 24, 27. So we're adding 3 each time. Good. You guys are killing it. All right. Now, they're making it a little harder. Now they're going to make you guess. What do we start with here? 4. So this one's counting by 4s. So 4, 16, 20, 28, 32, 36. Perfect. I love it. Good job. And the last one, they just make us guess. They put that 25 right in the center. So what do you think this one's going to be? 5. So we're going to go 25. Perfect. Did you like those? Then you will love this chapter because this is all about matrices and corresponding elements and comparing to, adding to, subtracting, multiplying. We're going to do all sorts of things with grids of numbers like this. Okay, very good. Any questions about these little puzzles? So it's a nice little opener. So I talked about we're going to have these grids of numbers. And we might have 2 rows and 3 columns, right? So if I have, if I have this, I'm going to say, we're going to talk about our rows first. So we have 1, 2 rows. And we have 1, 2, 3 columns. So this is a 2 by 3 matrix. Okay? Now, that's different from a It's hard to talk and do this at the same time. For me, anyway. Okay, that's different from a 3 by 2 matrix. Everybody see that? You go rows first. So 1, 2, 3 rows and 2 columns. Picture little Roman guys back in the ancient Roman days. I was watching a really cool History Channel show today, and they were talking about the way that they worked with water, made aqueducts and aquifer. They just did so much with so little engineering that was so perfect. But imagine this line of little Roman guys, a row of little Roman guys pushing up a column. Okay, and so they're pushing, they're going to push it up, right? So the rows have to come before the columns, right? You can't get the column standing up without the little rows of guys pushing it. So that's the way I remember rows and columns. Rows first, columns second. The rows go this way, the columns go this way. So that's after they push it up, right? Okay, so that's a little bit of trivia there for you. So now when we talk about adding, we have to look at corresponding elements. So here they're showing, so they're calling a matrix the capital letter. So this right here is matrix A. This right here is matrix capital B, right? And we can add these together. But look at how they show the elements in here. A, it looks like 11, A 12, but it's not. It's A, the row 1, column 1. Now I'm going to lose my voice after the grass incident. A, row 1, column 1. A, row 1, column 2. A, row 2, column 1. And A, row 2, column 2. That's what those sub numbers represent, rows and columns. Not 11, 12, and 21, 22. It's 1, 1, 1, 2, 2, 1, 2, 2. Right, so when we talk about these matrices, and that's the plural for matrix, I'm talking about both A and B matrix. So when we add the matrices together, we have to look at what are corresponding elements, and you add their corresponding elements. So if I add A plus B, the matrix, then I'm going to look at their corresponding elements. So row 1, column 1 is going to be added to row 1, column 1 of the other matrix. So let's look at an example. Here's two matrices, C and D. And they are both 2 rows, 3 columns. 2 rows, 3 columns. So they're the same size. Now they want to know what is it when we add these two together and what is it when we subtract these two together. So when you add and subtract them, they're going to yield a matrix of the same size. But it's going to have different values according to their corresponding elements. So let's do the first one, C plus D. When you have matrix C added to matrix D, you're going to add 3 plus 1. See, both of those are corresponding elements if they hold the same position in both matrices, okay? So it would yield this, 3 plus 1, which is going to be 4 in a minute. Now, then you're going to add 2 plus 4, and then the third one is going to be 4 plus 3, and then on the bottom row, -1 plus -2, I'm going to run out, so I'm just going to add them now. That's going to be a -3. And then a 4 plus a 2, 6. And then 0 plus 4 is 4. So that one would be 7, 6, 4. So the final matrix would be 4, 6, 7, -3, 6, 4. And there it is. Does everybody see that? So add the corresponding elements of the array. Corresponding elements hold the same position in each array, the same row, same column spot. right? And we do the same thing for subtracting them. So, I'm not the only one allergic to that, huh? So now we have C minus D, and pay attention to what's first. So the matrix C goes first, and we're going to subtract from that D. So they've copied them again, 3, 2, 4, negative 1, 4, 0 in red, and then D is 1, 4, 3, negative 2, 2, 4 right there. So now let's subtract. So it's going to be 3 minus 1 in the first spot. Row 1, column 1. Row 1, column 2, you're going to go 2 minus 4. And that goes in the same corresponding spot. And then 4 minus 3 in row 1, column 3. Now we're going to move to the second row, negative 1 minus negative 2. And notice that that's a minus, so put it in parentheses so you don't lose your sign. 4 minus 2, row 2, column 2, and 0 minus 4 for row 2, column 3. Now, do the math. So 3 minus 1 is 2, 2 minus 4 is negative 2, 4 minus 3 is 1, minus and minus goes to plus, so negative 1 plus 2 is 1, 4 minus 2 is 2, and 0 minus 4 is negative 4. And this final matrix is your answer. And it's that easy. Yes, ma'am. No. No, I don't expect you. That's so simple that I think you can. I'm not going to hold your toes to the fire for that one. The question was, do we have to show this part? No, I don't even show that part. Right? I just do it as I go. When it gets more complex, like when we're doing scalars and it's a couple lessons tomorrow, the next day, then yes, we will, but for these, no. Any questions over this? Okay, get your work and let's take a couple of minutes. Let's work the first one together. Come on. It's not letting me move it. Oh my goodness. Okay. Come on. All right. Well, I don't know. I'll just write over it. Okay, so for this first one, we're going to have, this is actually a plus in between here. If you're missing the plus sign between those two, pencil that in. But my worksheet was missing the plus. It looked like they were multiplied, but they are added. All right, so the first one, you're going to go 2 plus negative 4, which is, and I'll just start it over here. So 2 plus negative 4 is negative 2, right? And then 4 plus negative 1 is 3. And then 5 plus 3 is 8, and negative 7 plus 5 is negative 2. So there's your matrix answer. Are there any questions about that? All right, work 2, 3, 4, 5, and 6. So you've got subtract, add, subtract, add, subtract. So be careful, all right? And I'm going to give you, let's do 3 minutes. I think you can get it done in 3. Okay? And then we'll come back and check it. Oh, now it's going to let me move it. Crazy. Okay, so let's check. Does anyone have any questions? Okay, so for number 2, your first row should be 4, negative 4. Row 2 is 4 and 5. On number 3, you've got on the first row 2, 9, negative 5. Second row should be 0, 9, 7. Number 4, you should have negative 3, negative 5, 5, negative 6, negative 4, and 4. On 5, you should have 5, 1, next row 3, 8, and last row 9, 5. And number 6, you should have on the first row negative 4, negative 5, and the second row 5 and 3. Are there any questions on those? Be really careful with your signs. Okay? All right, then we will move on. So now we're going to learn about matrix equations. It's an equation in which the variable is a matrix. So look, you've got a matrix here. So 3 rows, 3 columns. So we've got a 3 by 3 matrix. Into that we're adding matrix A, which is unknown. And we're going to say when you add A to this first matrix, you're going to have an answer of this matrix. So what is matrix A? What do we add to it to get that? Well, there's lots of ways to do this. You know, it's just simple algebra. It's like saying 5 plus x equal 11. So how would we solve that one-step equation? We would subtract 5 from each side, right? And then we would say that x is equal to 11 minus 5, which is 6. So we're going to work this much the same way. We're going to solve for A because we're trying to figure out what is matrix A. So what do we need to do? We need to subtract this matrix from both sides. So basically, let's see if I can do this quickly. So I'm going to add that over there, and then it gets rid of, that's like subtracting, start over. Subtract this matrix from both sides. See? So we're subtracting this, and then this goes away. So I have A is equal to this matrix minus this matrix. Is everybody with me? So now, to solve for matrix A, we're going to now just perform the math. So A is equal to 8 minus 1, which is 7, 11 minus 0, which is 11, 9 minus 12, which is negative 3, negative 5 minus negative 3, which is negative 8, 5 minus 5, 0, 2 minus 9, which is negative 7, 10 minus 7, which is 3, 7 minus 8, negative 1, and 8 minus negative 2. So that's going to be a 10. All right, so there's my answer. That is my matrix that's missing. Is everybody with me there? Any questions? All right. Then we don't have to do all that. Okay, so let's go to number 7, 8, and 9. And then 10 is just an error analysis. They're saying Maria added these two matrices, and she found a sum of this, 0, 7, 4, 3. What error did she make, and what's the correct sum? So I want you to do all 4 of these now, okay? And then we'll come back and talk about them in another 3 minutes. So work on those now. Let's do the first one together just to get started. So again, you're going to subtract this from each side. 7, 3, negative 1, and 5. So you're going to subtract that over here. It's hard to write that small, okay? And then this goes away. So now perform the math. X is equal to 4 minus 7, which is negative 3. 5 minus negative 1, minus and minus goes to plus, so that's 6. 8 minus 3, which is 5. And 2 minus 5, which is negative 3. That's your answer. Any questions on that first one? Before you do 8, again, this is just algebra. Remember, if I subtract this matrix from both sides, minus that over there, then I'm left with the negative x equals this matrix minus that matrix. Well, don't forget, we've got to get rid of that negative. So switch all the signs. That goes to plus, minus, plus. So you end up with negative first matrix. Another way to look at this one would be to say, okay, well, I'm just going to subtract x from each side, and then that goes away. And now I need to get rid of this. So now subtract this minus that is equal to that. So add x to each side. I think I said subtract, right? So you're going to have x equals this minus that. It's like saying 3 minus x equal 7. What are you going to do? Well, let's add x to each side to get the x positive. And now we've got to subtract 7 from each side to isolate our x. So you have x equal 3 minus 7. Same principle up here. Okay? All right. So I'll give you 3 minutes. That was loud, sorry. It's got to go one more time. Who needs more time? Is everyone through with these? Okay, we'll just go ahead and stop it here. All right. All right, so let's look at 8. So I said we could just add x to each side and then subtract the second one from each side. So you're going to get 2 minus negative 5, which is going to be 7. and then 7 minus 1, which is 6, and then 9 minus 3, which is 6, and negative 3 minus 4, which is negative 7. Okay? Did everybody get that? Any questions on that one? All right, and number 9. So here we're going to add this matrix to each side. So you end up with x equals this. Yeah, you're adding, so it's going to be plus. Okay, equals this plus this. Okay, everybody with me? You're just going to add them. So now x is equal to 2 plus 3, 5, 8 minus 6, which is 2, negative 1 plus 4, which is 3, and 5 plus 2, which is 7. So 5, 2, and 3 and 7 for the second row. Why am I adding? Because you've got x minus this matrix. You've got to solve for x. So you've got to isolate x. So you've got to add this matrix to both sides, which causes it to be x equal this plus that. Does that make sense? Because see, you had, they're saying if I start with the matrix and I take this one away, I get this answer. What is my missing matrix? So it's just simple algebra, like an x minus 3 equal 12. What would you do? Add 3 to each side. Well, same thing here, but we're dealing with the matrix. Add this matrix to each side. So it's x is equal to the sum of those two matrices. Is that good? Any other questions? All right, so what was the error? What error did she make? She added them in the wrong order. She didn't use corresponding elements. She should have done row 1, column 1, row 1, column 1. And that would have been what? 5 minus 2, which is 3. So, but she didn't do that. It looks like she did 5 plus negative 5. So she worked from the outside inwards. See that? And outside inwards, right? So she went the wrong, didn't use corresponding elements, so write their correct matrices, and then we're going to move on. For any matrix or matrices, the additive identity matrix is our zero matrix. A zero matrix is with the large slanted O. That means it is a zero matrix. It means it's full of zeros. And when you take a matrix like 3, 2, 5, 6, well, what do I add to that to get a zero matrix? Well, that's going to be your additive, the opposite additive inverse. So it would be negative 3, negative 2, negative 5, negative 6. Everybody see that? And those are the things we're dealing with next. So look at this first one. What are the following sums? Well, if I add a zero matrix to any matrix, my answer is just going to be the initial matrix, right? 1 plus 0 is 1. 2 plus 0 is 2. 5 plus 0 is 5. And negative 7 plus 0 is negative 7. So you end up with the same matrix when you add a zero matrix. Everybody with me there? Any questions on that? Now, the additive inverse is what happens. It's the matrix that you add to another matrix to turn that to a zero matrix, the solution to a zero matrix. So it's just the opposite of all the numbers. So 2 plus negative 2 is 0. 8 plus negative 8 is 0. Negative 3 plus 3 is 0. And 0 plus 0 is 0. It's just what are you going to add? The opposites. which brings us to 11, 12, 13. So let's take 2 minutes on this one, and we've got to hurry and finish this up. So do this one quickly. Let's do 11 together. What are we going to end up with? 3 plus negative 3 is 0. Negative 1 plus 1, 0. Negative 5 plus 5, and 8 plus negative 8. So we end up with that 0 matrix. Okay, now work 12 and 13. Okay, so for 12, what do we get? Negative 4, 9, negative 7, and 5. Yes, just that first matrix. How about the second one? It's a 0 matrix. Any questions on those? So the two terms here was additive inverse. It's what you add that turns everything to 0. And 0 matrix is just a matrix full of zeros, and it's denoted with the slanted capital O. Okay? All right, so I'm not going to go over these. It's just the stuff you've seen all your life about the properties, but the same properties apply, same terminology basically for your associative, identitive, and all of those things. Now let's talk about what equal matrices are. If I have 0.25 in row 1, column 1, and 1 over 4 in row 1, column 1 of the second matrix, those are the same. They're just represented differently because 1/4 is 0.25, and 1.5 is 1.5, and negative 3 is negative 3, and 4/5 is also 0.8. These are equal matrices. Now let's look at our last thing. What values of x and y make this equation true? Well, if these are equal matrices, it means that their corresponding elements are equal. So 9 is equal to 9. It also means 3x plus 1 must be equal to 16. So if I want to find out what x is, I'm going to use that property. 3x plus 1 equals 16 and solve for x. Subtract 1 from each side, and then divide each side by 3, and I get x is equal to 5. Okay, so we've solved that. Now let's do y. 2y minus 1 equals negative 5. So 2y minus 1 equals negative 5. Add 1 to each side, and I get negative 4. Divide each side by 2, and I get negative 2. So y is equal to negative 2. And then 10 is equal to 10. So I've solved for x and y. And what did I say it was? I forgot what the first one was already. Y was negative 2, x was 5. So it's going to be C. X equal 5, y equal negative 2. Oh, there it is. Correct answer is C. So any questions on how to solve for those variables? Flip it over on the back page and spend the rest of the hour doing we'll do 14 together, but you'll do 15, 16, 17. So it says find the value of each variable. So for 14, we're looking for x, y, and z. So to find x, it's going to be 4 plus negative 5, which is what? Negative 1. So x is negative 1. For y, let's see, it's going to be negative 1 plus 7, which is 6. And then for z here, it's going to be 6 plus negative 3, which is 3. And that's how you do these. Okay, you have just enough time to finish this. So on 15, you're looking for x, y, and that's it, x and y. For 16, you're looking for x, y, and z. And then 17, you're looking for a, b, and c. All right, so solve those real quick, and then we'll go over the answers, and you'll be done. Hooray! That concludes the addition and subtraction of matrices. So let's give you about a minute. Ooh, that was loud. Okay. So for 15, what'd you get for x? 9. And y? 3. Good. And then 16, x is equal to? -2. Did anybody get y yet?
7.
Okay, let's see if that's what I got. Yes. Okay, let's see. So we've got 2 minus y equal -5. So we're going to go subtract 2 from each side, and you get a -7. And now you've got to clear the negatives. So divide each side by -1, and you get that y is equal to a +7. So y is +7. Does everybody see that? Hannah, please remove your earbuds. Okay. And then z, you're going to have 2z plus 1 equal -7. So that comes out to be -4 is correct. And if you didn't get that, you need to rework these at home. Okay, because this is all you're going to have. This paper that you're working right now, no notes, no journal, no book, no study guide, just these assignments is what you're taking into your test. Okay, how about 17? Do we finish that, or we need a little more time? Okay, a is equal to what? 5, that's correct, because you have -5a equal -25, so it's going to be a equals 5. Okay, and b is 2, which is correct, and c is equal to 4, which is also correct. Good job, guys. That concludes our lesson. Any questions? Don't lose this, and you will turn all these in with your test next Monday, okay? So we'll do 12-1 today, 12-2 tomorrow, which is about matrix multiplication. Then it gets a little harder with determinants and inverses, 12-3, which gets you ready for calc and pre-calc. And then 12-4, the last one is inverse matrices and systems. So that'll get us through Friday, and then the test is Monday, and then we're finished with the book. So thank you. That concludes our lesson.